Welcome back. In a series of lectures, we will discuss design of a battery pack. Here, we are not referring to an individual cell, but we are referring to a collection of individual cells to meet certain design specifications. There are three important features of design when it comes to a battery pack. These are to do with the discharge time of a battery, the nominal voltage that can be provided by a battery, and the energy that can be provided by a battery pack. So these will be elaborated briefly in the next slide. So the important features of a battery pack are the following. We will take up each of this topic in the next few lectures, but this slide is supposed to give you a broad overview of the issues we would be discussing. For example, the discharge time of a battery pack depends upon the rate of discharge. Okay, so it is very crucially dependent on how quickly you tend to discharge a battery. So typical discharge time of a battery is in the order of hours. The nominal voltage of a battery is the output voltage that you can get from a collection of individual cells. The battery chemistry would determine the voltage that you can get from an individual cell. For example, if you have a lead acid battery, from each cell of a lead acid battery, you may get 2 volts. If you have a lithium ion battery, you may get 3.5 volts. But this is not what is being referred to when you specify the nominal voltage. If you have a collection of individual cells, what is the overall voltage that can be obtained from a battery pack? That is what we refer to by nominal voltage. Typically, the nominal voltage of a battery would decrease with usage. So we are interested in the maximum voltage and the minimum voltage that can be obtained. Energy of a battery is specified in watt hours. So this is a very important feature. This refers to the capacity of the battery. This is also correlated to the average power and how quickly you discharge a battery. The weight or the mass of a battery is specified in kgs. This is very critical when it comes to transportation batteries, the batteries that are used in electric vehicles and so on. So you want them to be light. So this is an important feature. This is related to not only the battery chemistry, it is also correlated to energy stored in a battery. Volume of a battery is specified in meter cubed. It's close related to the energy stored in a battery. Peak power is specified in watts. This is an important feature, although a battery is not necessarily a electrochemical power device. If you're thinking about providing power, you are usually you will be using an electrochemical double layer capacitor. But even otherwise, even though battery is a energy storage device, peak power is an important feature of a battery. Typically, we are interested in knowing what is the power that can be provided by a battery when the battery provides power using a short pulse in a fixed time, for example, in 30 seconds. This is important, for example, when you start a car. Okay, so typically a battery provides that pulse of power. So what is the peak power of a battery is an important feature. Cycle life is another important feature. So as you charge and discharge a battery, certain features of the battery decay gradually. The capacity and the power it can provide gradually decays. So the number of cycles a battery can be operated before certain features decrease by about 20%, for example, is an important specification. You may have, let's say, 500 cycles, okay, or even 5,000 cycles. Okay, so this is an important specification of a battery. Batteries are expected to operate in a window of temperature. For example, in a winter of Western countries, the temperature can be as low as minus 18 degrees centigrade. The resistance will increase. Sometimes, in some cases, for example, if you're operating a battery in Kanpur, for example, Kanpur summer, the temperatures can go to, ambient temperature can go close to 50 degrees centigrade. So the operational temperature window can vary for a battery. So it is important to know under what temperature window a particular battery can operate. We won't talk a lot about calendar life here. This is specified in years. The science underneath a calendar life is beyond the scope of these lectures, but three things are connected: cycle life, calendar life, and shelf life. Okay, so these three things are correlated, but we won't elaborate much about these topics in this set of lectures. So if you take a particular cell, an individual cell, we have discussed the voltage current performance of individual cell, but in these set of lectures, more than an individual cell, what we are interested is when the individual cells are connected in series and parallel, this bunch of cells is what is referred to as a battery pack. So when cells are connected in series, I cell remains the same across this string of batteries, but the voltage adds up. And the current that can be provided from a battery pack is because of the different parallel strings that exist in this connection. For example, if there are M cells here, that number is determined by the overall voltage that can be provided by a battery. For example, it can be, let's say, 360 divided by the voltage of a particular cell. So this divided by this gives you 96 cells connected in series. So if you have, let's say, two strings, N is equal to 2, the overall number of cells in a battery pack is M times N, that is 2 times 96, which is 192 cells in a battery pack. Given this, you can specify the capacity and energy of a battery. For example, the capacity can be obtained in two ways. E of a cell, the energy provided by an individual cell, divided by the voltage of an individual cell, or the energy provided by a battery pack divided by the total number of cells in the battery pack times the voltage of a particular cell. So this is the overall energy provided by the battery pack, number of cells, voltage. So the capacity is specified in ampere hour units. So this battery pack has a capacity of 33 ampere hour. In the next lecture, we will discuss the battery layout using a specific cell design. Thank you.